Good morning, welcome to Lionheart Academy. This is Richard Tyne. We are continuing our trigonometry lesson. Today is our trigonometry lesson 44, double angle and half angle formulas. We start talking about different identities, and this is part of the identity formulas that we've been learning. We start with the basic three identities, and we have talked about sum and difference formulas. And so based on sum and difference formula, we are able to derive more formulas. So today let's talk about double angle and half angle formula. So double angle basically is the function of twice an angle. Alright, so let's go ahead and start with sine of 2 theta. Okay, so sine of 2 theta it's a double angle because it's twice of theta, or it's theta plus theta. We can derive this, we can come to the conclusion of using sum and difference formula. So because 2 theta is simply theta plus theta, so both the first angle and the second angle are the same. So let's use the sum and difference angle formula. Okay, so it's going to be sine theta cosine theta plus cosine of the first angle times sine of the second angle. Because both of them are the same, okay, theta and theta is the same angle, so we actually have two expressions. They are exactly equal to each other, so we can combine them to become 2 times sine theta cosine theta. So this is the equivalent expression of 2 sine of 2 theta, 2 sine theta cosine theta. Now, why do we want to relate this? We want to be able to do this so that when we have a double angle, or actually we can have more than just double angle. When we have things like this, we can break it down to simpler expressions. Now, so basically, this is the formula: sine of 2 theta equal to 2 times sine theta cosine theta. And this works in different ways also. Okay, I'm going to try to write it a little bit better. Okay. 2 sine theta cosine theta. Now there's another way we can write this. We can actually write the sine theta is equal to 2 sine of theta all divided by 2 and times cosine of theta divided by 2. Now why can we do that? Because the proportion is the same. This is as you can see, the relationship between this angle up here is always going to be twice of that angle. So if this angle is theta, this is going to be theta over 2. Okay, so this is sine of 2 theta. Now let's look at cosine of 2 theta, which is cosine of theta plus theta. Alright, cosine theta plus theta is going to be equal to cosine theta times cosine theta minus sine theta sine theta. Okay, so in this case we're going to come up with cosine squared theta minus sine squared theta. So this is definitely one way to express cosine of 2 theta. Now what's another way to do this? Now because we remember, okay, their Pythagorean identities, cosine squared theta plus sine squared theta equal to 1. So I can replace cosine squared theta with 1 minus sine squared theta. So I can write it like 1 minus 2 sine squared theta. Okay, I can also replace sine squared theta with cosine squared theta, right? So 1 minus cosine squared theta. We can replace sine squared theta with 1 minus cosine squared theta. So this will be cosine squared theta minus 1 plus cosine squared theta when we open the parentheses. So altogether we have 2 of them, 2 cosine squared theta minus 1. So there are several ways to represent cosine of 2 theta. In fact, there are 3 ways. So this is cosine squared theta minus 1. Cosine squared theta minus sine squared theta, or it can be 1 minus 2 sine squared theta, or it can be 2 cosine squared theta minus 1. Now the question is, when do we use which? Well, it all depends on the situation, depends on the problem that you're working with, and what kind of simplification are you looking for. If you want to convert cosine to sine, purely sine, then you go ahead and write in this 1 minus 2 sine squared theta. If you want to convert them and then stay with cosine, then use 2 cosine squared theta minus 1. But in other situations where you might need both, you would go ahead and use cosine squared theta minus sine squared theta. Okay, So, and then we can also apply the proportion of half angles here. So if I write cosine of sine theta, I can write it as cosine squared theta over 2 minus sine squared theta over 2. Okay, so we can divide this angle by 2 and the remainder proportion. Now, what about tangent of 2 theta? Well, tangent to theta is tangent of theta plus theta. Okay, so this is we're going to use the double angle formula for tangent. So it's tangent theta plus tangent theta divided by 1 minus tangent theta times tangent theta. So this becomes 2 tangent theta divided by 1 minus tangent squared theta. Okay, 1 minus tangent squared theta. So that's the double angle formula for tangent theta. So tangent of 2 theta will be equal to 2 tangent theta divided by 1 minus tangent squared theta. Alright, let's box this up. Alright. Okay. Now, how can we extend the uses of double angle formula? They don't just have to be double angle. For example, let's go ahead and show you some examples here. For example, sine of 4a, right? Now you say 4a is not double angle. Well, actually it is, because 4a is double of 2a. So it's sine of 2a, cosine of 2a. And we can further simplify this, because we know sine of 2a is 2 sine of a and cosine of a, and we know cosine of 2a can be let's say 1 minus sine square of 2a, 1 minus 2 sine square a. Alright, so we can actually express everything in terms of sine a. So this would be 4 sine a cosine a times 1 minus 2 sine square a. Alright, and I can actually open this up. So this is 4 sine a cosine a minus 8 sine cube a cosine a. So as you can see, we can actually open this up and express everything in terms of sine a and cosine a. So this is more than just a double angle formula, and we can actually do let's say cosine of 6a as well. Let's try this. So this could be cosine square of 3a minus sine square of 3a. Okay, that's right. Okay, this is 3a, and we can even do a fraction. We can even apply this formulas to a fraction. Cosine of 2/3 a. Well, what's 2/3? 2/3 is twice of 1/3, right? So this can be written as 2 cosine square of 1/3 a minus 1. Okay, 1/3 a being the angle there, because it's half of 2/3 a. Okay. Alright, so let's go ahead and move on. We're going to look at the next set of formulas. So we look at the sum and difference formula. We look at the double angle. Now let's take a look at the function of half angles. Okay, so it's half angle formula, half angles formula, half angle formula. Okay. Okay. I'm sorry, I'm not writing very well this morning. Half angle formula. Alright, so let's actually start with cosine 2 theta, okay, equal to cosine squared theta minus sine squared theta. Okay, we're going to start with this formula, the double angle formula. Now, as you can see, we can go ahead and convert this to half of the angle, right? So if I write, instead of write 2 theta, I can write 1 theta here. That means every other angle has to be halved. Okay, the proportion is divided by 2. And actually, I can just go ahead and write it like this: 1 minus 2 sine squared theta divided by 2. Okay. So let's go ahead and solve for sine squared theta. So I'm going to move the 2 sine squared theta over the other side, move the cosine over here. So I have 2 sine squared theta over 2 equal to 1 minus cosine of theta. Okay, so I exchange those expressions, and I divide both sides by 2. So as you can see, sine squared theta over 2 is equal to 1/2, right? 1 minus cosine of theta divided by 2. Okay, so this is one way to express, and then I can solve for sine of theta over 2 by taking the square root on both sides. So it's 1 minus cosine theta over 2, plus or minus. Now make sure you have the plus and minus. Now why do we have the plus minus? Because when we divide the angle by 2, the angle might not be in the same quadrant with the original angle theta. So what happens is that the answer might have to change signs depending on the quadrant. Now there's another way to express this. You can write sine of theta equal to sine of square theta equal to 1 minus cosine of 2 theta divided by 2. So this is another way to express the same formula. How do I get it? Well, basically, I start with this formula. Instead of putting theta over 2, I just put theta there. So basically solving, it comes from this equation as well. Comes from the double angle formula as well. So this is sine. So we can use this expression, or we can use this expression depending on what you need. And another name for this is called power reducing formula, because as you can see, if you have sine squared theta, you want to reduce it to instead of using cosine square or sine square to express sine square theta, instead of using another square term to express it, you can use 1 minus cosine 2 theta divided by 2. So you can reduce the power. However, you do have to use the double angle of it. Okay. All right. Now let's take a look at this. So we start with cosine and of 2 theta equal to let's see. Now let's go ahead and do this. Cosine 2 theta equal to 2 cosine squared theta minus 1, right? So let's go ahead and solve for 2 cosine squared theta equal to cosine 2 theta plus 1. Okay, cosine 2 theta plus 1, or 1 plus cosine 2 theta. You can keep that in form. So cosine of squared theta will be equal to 1 plus cosine 2 theta divided by 2. So this is one of the expressions that we can use. But let's say we don't want to use the cosine theta and cosine 2 theta. Let's go ahead and use the half angle. So it's cosine squared theta over 2 equal to 1 plus cosine theta divided by 2. Okay, so it's 1 plus. So therefore, this means that once we take square root, cosine theta over 2 is plus minus square root of 1 plus cosine theta divided by 2. Alright, so this is the half angle formula, and this part is the power reducing formula. Okay, you can, it's also called half angle formula, but sometimes also called power reducing. Alright, so let's get the tangent one. Okay, so what about tangent? So how do we get tangent of theta over 2? Well, let's go ahead and use sine of theta over 2 divided by cosine of theta over 2 and see what happens. So sine of theta over 2 is plus minus square root of 1 minus cosine theta divided by 2, and cosine is plus minus square root of 1 plus cosine theta divided by 2. As you can see, the plus minus sign will cancel each other out, because we don't really have to worry about, well, actually I guess we can state the cosine. I'm sorry, the plus minus sign can stay there, because we will have two different answers. We can always have two different answers, but the denominator is the same, so we can combine the two radicals and to become 1 minus cosine over 1 plus cosine. So this is one way to use it. Okay, but this is there's also another way to simplify this expression a little bit more. All right, to simplify this expression a little bit more. So let's go ahead and do this. So tangent of theta divided by 2 is equal to plus minus square root of 1 minus cosine 1 minus cosine theta divided by 1 plus cosine theta, right? So what we can do is we can do some operations here, trigonometry, algebraic operations here, by multiplying the denominator and the numerator by 1 minus cosine. So let's go ahead and try to see what happens here. So this will become plus minus square root. This is going to be 1 minus cosine theta squared, because there are two of them. Okay, but now the denominator is 1 minus cosine squared theta, right? Now we recognize that is equal to sine squared theta. Okay, and this is 1 minus cosine theta quantity squared. So we can actually take the square root, and if we take the square root, it will be 1 minus cosine theta over sine theta. Okay, so this is another expression, very useful expression for tangent of theta over 2. Alright, now, but we can actually do something else to this. Okay, we can write this in another form that's quite useful. So let me go back to the beginning to derive it again. So tangent theta squared 2 equal to plus minus square root of 1 minus cosine theta divided by 1 plus cosine theta, right? Alright, so this time I'm going to multiply this by 1 plus cosine theta instead of 1 minus cosine theta. And let's see what happens, okay? So I multiply by 1 plus cosine theta on top and bottom. So the top becomes 1 minus cosine squared theta, okay, because it's 1 minus cosine times 1 plus cosine. The denominator is 1 plus cosine theta parentheses second power. So this becomes plus minus square root of sine squared theta on top, and then 1 plus cosine theta quantity squared on the bottom. So after we take the square roots, on the it will become sine theta divided by 1 plus cosine theta. So as you can see, this is an equivalent form of tangent of theta over 2. So we can actually have several forms that we can use. We can use this over the radical form. We can use the one without the radicals. Okay. Alright, so half-angle formula are very important. They also can help us get some kind of angles. For example, let me go ahead and just show you very quickly. If we have tangent of 15 degrees, right? So what would tangent 15 degrees be? Well, it's going to be sine of 30 degrees over 1 plus cosine of 30 degrees. So this is one expression that I can use just right off the bat. And I can actually simplify this. Sine of 30 is 1/2, cosine of 30 is square root over 2. Okay, I can multiply everything by 2, the numerator and denominator by 2, so it would be 1 over 2 plus square root 3. And I can convert this to some other form by multiplying the numerator and denominator by the conjugate. Okay, like this. 2 minus square root 3 is the conjugate. So that will give us 2 minus square root 3 divided by 4 minus 3, which is 1. So it's simplified it down to 2 minus square root 3. So that's a good way to help us find the exact value of tangent 15 degrees. Okay, so let's go ahead and stop right here. Tomorrow we'll continue to talk about other formulas. So if you have any questions or comments, please leave your questions and comments in the comment sections. Please share, help us spread this channel. And if you have any other friends or classmates who need help in math, please go ahead and get this words around, get the words out to share the channel with other people. We appreciate that, and we hopefully see you come back and join our trigonometry lessons in the future. Thank you.